Good morning, students. Today topics of discussion are asymptotic analysis, abstract data type, data structure in C language and array. Asymptotic analysis. Let us start with asymptotic analysis. Asymptotic analysis of an algorithm is used to measure the running time performance of an algorithm on large value of n by defining the mathematical foundation. There are three types of analysis we can perform on the algorithm. First is the worst case analysis, next is the average case analysis, and next is the best case analysis. Worst case analysis defines the input for which the algorithm takes the huge amount of time. The average case analysis defines the input for which the algorithm takes the average amount of time. The best case analysis defines the input for which algorithm takes the least amount of time. Next is the asymptotic notation. There are three types of asymptotic notations: big O notation, omega notation, and theta notations. Let us see one by one. Big O notation. Here O stands for order of the algorithm. It is concerned with what happens with very large value of n, that is input to the algorithm. It measures the worst case of time complexity or longest amount of time algorithm takes to complete their operation. It represents upper bound of an algorithm's running time. We can define the asymptotic notations as follows. If fn and gn are two functions defined for positive integers, then fn is big O of gn, or fn is on the order of gn if there exists positive constants c and n0 such that fn is less than or equal to c times gn for all n is greater than or equal to n0 and c is greater than 0. In this figure you can see the x-axis represent the value of n, increasing value of n, and the y-axis represent the rate of growth. This figure depicts that the function fn, the growth of the function fn does not increase with the function gn. Means it always, the rate of growth of the function fn is always less than the function gn for every value of n that is greater than or equal to n0. Here in this table you can see there are two columns, one is the function gn and next is the big O of the function gn. The first entry is in column gn is 10 and big O of this 10 is O1. 1 indicates the constant time, and here you can see the 10 represents the, when you execute the algorithm, it takes the 10 steps, okay, to execute the algorithm. Therefore, the complexity of this algorithm is a constant time. Here 1 represents the constant time. If gn is 2n power 3 plus 1, then big O of this function gn is n power 3. The maximum power on the input value n. If it is a 3n square plus 1, then big O of this function is n square. If function is 2n power 3 plus 3n square plus 5n minus t minus 10, then again the big O of this function is n power 3. This way you can determine the big O of any given function. Next, omega notation. This notation represents the lower bound of an algorithm's running time complexity. Next, it measures the best amount of time an algorithm possibly take to complete our best case time complexity. Okay. Again, we can define the omega notation as follows. If fn and gn are two functions defined for positive integers, then fn is omega of gn, or fn is on the order of gn if there exist positive constants c and n0 such that function fn is greater than or equal to c times function gn for all n is greater than or equal to n0 and c is greater than 0. This figure depicts that the rate of growth of the function fn is always greater than the rate of growth of function gn for every n is greater than or equal to n0. Theta notation. This notation decides whether the upper and lower bounds of a given algorithm are same or not. We can say average running time of an algorithm is always between lower bound and upper bound. Next, if upper bound and lower bound gives the same result, then the theta notation will also have the same rate of growth. We again define the function theta notation. If fn and gn are two functions defined for a positive integers, then fn is theta of gn, or fn is on the order of gn if there exists positive constant c1, c2 and n0 such that fn is lies between the c1 g1 and c2 gn. For all n is greater than equal to n0, c1 is greater than 0 and c2 is greater than 0. This figure depicts that the rate of growth of the function fn always lies between the c1 g1 and c2 gn. Next is the abstract data type. To measure or manage the complexity of the problem, the computer scientists use the concept of abstraction, which allows them to focus on the essential things and ignore the unessential things. But you should keep in your mind, nothing is essential and unessential. It depends on our requirement, what we want to study. Okay, this is a concept of handling the complex problem, focusing on the things for which we are interested and ignoring the rest of the things. Okay. Abstract data type is the way we look at a data structure. It is concerned with a data structure. Stack and queue are perfect example of an abstract data type. Suppose we want to use the stack as a data structure in our program. We will use the functions provided by the stack. Actually, the stack provides two functions. One is the push operation and next is the pop operation. Push means push the item on the stack and pop means take the items from the stack. To use the stack as a data structure, we will use the functions of the data structure. We are not concerned how the stack is implemented in the language. Either it is implemented in the C language or it is implemented in the C++ language. We focus on the functions provided by the stack. Okay. It focuses on abstract data type, focuses on what the structure does and ignoring how it does its job. Okay, means implementation part of the structure. Okay. Next topic is the data structure in C language. We can classify the data structure in the C language into two groups. One is the built-in data structures. We can say the primary data types, and next is the user-defined data structures, means derived data types. This primary data types is classified into the integer, float, double, character, and pointer. And this derived data types is classified into arrays, list, and files. List is again classified in the linear list and the non-linear list. Linear list is again classified in stacks and queues, and non-linear list is again classified into the trees and graphs. In the previous videos, we have discussed in details about these concepts. Okay. Next is now we are going to consider, now we are going to design, now we are going to study array as a data structure. What is the array? Array is a data structure. What is the array? You already know in the C language. Array is a collection of similar type of data items. It is stored in a linear fashion. It is an example of a linear data structure. You can say it is the simplest data structure. Each element of the array can be randomly accessed using its index number. Let us see how we will declare the array in the C language. First, we write the name of the data type, followed by the name of the array, and followed by the size of the array. What is the purpose of writing the data type? It focuses on the kind of value the array stores. Which type of information we are going to store in the array? Name, what is the purpose of the name? To identify the array. And size, give the maximum number of values that the array can hold. Let us take a specific example. Here we are going to define array B, which stores the integer type value. And how we will do it? First, we write the name of the data type of the items. So int is a data type, followed by one blank space, followed by, you can say, the name of the array is B, and next is the size of the array. Here you can see the 6. Okay. So 6 tells the maximum number of elements an array stores. Okay. So index varies from, in the C language, 0 to 5. Okay. This 0 indicates the lower bound and 5 indicates the index 5 indicates the upper bound. Okay. And to determine the length of an array, you can use the formula upper bound minus lower bound plus 1. Is it clear? Now, let's see the indexing of an array can be defined in 3 ways. Zero-based indexing. In the C language, we always define the zero-based indexing in the C language. Next is the one-based indexing, and next is the n-based indexing. In the zero-based indexing, the first element of the array will be array 0. In one-based indexing, the first element of the array will be at the position 1. In n-based indexing, the first element of the array will be at position n, array n. Okay. So there are 3 common ways we can define the indexing of an array: zero-based indexing, one-based indexing, and n-based indexing. In the Pascal language, one-based indexing is used. In the C language, zero-based indexing is used normally. But you may change it. This is the operations on the array. We can perform these types of operations on the array. Traversing an array means visiting each element of the array. inserting an element in array, searching an element in array, deleting an element from an array, merging two or more arrays, sorting an array in ascending or descending order. Let us take the one operation on the array, insertion operations. In this, we consider the three types of insertion on the array: inserting at the end of the array, inserting at the front of the array, and inserting the item in the middle of the array. Let us take the first case, inserting at the end. We want to insert an item at the end of the array. Let us take n as the number of items in the array. And suppose A is the array. Name of the array is A. And here I am not going to give the whole algorithm, some part of the algorithm. Suppose we want to insert an item at the end of the item. What you have to know? We must know the last element of the array. If you know the index of the last element, then it is very easy to insert an item in the list. The question is, how will you know the last element index? Very simple. If you know the number of items in the array, simply in the C language, -1. Total number of items in the list -1 gives the index of the last element. For this, the first step, identify index of the last element in the array. And this is, let us take the last index of the array is k, and k is n-1. Next step, very simple, putting the item at the place k plus 1. A followed by the index k plus 1 is equal to item. And next step, stop the algorithm. With the help of these steps, we can design the entire algorithms, and we convert this algorithm into the C language. It is very, if you know the algorithm, then it is very easy to convert the algorithm into the corresponding C language. Next, suppose we want to insert at the item at the front of the array. Again, let us take n is the number of items in the array, a is the array, and x is the item to be inserted in the array. Again, the step first is the identify index of the last element. And how will you do it? Simply n-1. And let us take the last index is L. So L is n-1. Next step, take a variable k and put the value 1 to the variable. Next step, repeat steps 4 and 5 until this k becomes greater than n. And what is the n? N is the, what is the n? N is the total number of items in the array. Step 4 is AL plus 1 is equal to AL. Actually, what we are doing, we are shifting all elements in the array one position in the right directions. Okay, AL plus 1 is equal to AL. And next, we decrement the value of L by 1. L is L minus 1. And repeat these two steps until this k becomes greater than this n. And next step, we put the x at the place L. So AL is equal to x. Next step, stop the algorithm. Okay. Now convert this algorithm into the corresponding C language. Okay. Next, inserting the middle. Suppose we want to insert an item at position POS at any specific position. Okay. N is the number of items in array. N is the index of the last element in the array. So first steps, we initialize I is equal to N. What is the N? N is the total number of items in the array. Next step, repeat steps 3, 4 until I becomes less than the position where we want to insert an item. Next step, AI plus 1 is equal to AI. And next step, I is I minus 1. What we are doing in these two steps? We are pushing all elements after the POS the right direction 1 positions. Okay. Step number 5 is N plus 1. Next step, A POS is equal to X. With the help of these steps, we can write the complete algorithm. Is it clear? I am not writing here the complete algorithm. I am leaving these things for you. Okay? I mean, I am here only giving the concept. How will you do the activities? How will you design the algorithms? Okay? Next, these are the references you already know. So in this video, we have seen the basic concept of the asymptotic analysis. Actually, we have, in this video, I have not gone in the details of the asymptotic analysis. Okay. Here we simply know what is the asymptotic analysis. Okay. Next is the abstract data type and next is the array. Some portion of the array I have covered in this video. In the next video, we will see more concepts, more things on the array. Okay. Any questions? Questions are always welcome. You can give your questions on my email or you can say my WhatsApp. Thank you very much for watching this video and listening this lecture.